You've built a product or system powered with AI, but you don't really like the answers. Sometimes they're not specific, not relevant, or not accurate. And you're wondering, okay, how can I help AI to answer with more your knowledge that you have? This is really a common challenge that users of AI facing because most of the LLMs are trained on the general internet data. They don't know the structure of your company, your business, your product, or your more recent product updates. And you want to find a way how to fix that. So basically, there are three options to help AI to answer with the data that you know. First one is prompt engineering. Basically, this is about crafting your prompt this way so that you provide the context about your business. Second option is fine-tuning. Basically, I guess this is the most advanced option because you need to retrain the LLM with knowledge that you have. And the third option is RAG, Retrieval-Augmented Generation. Basically, you provide the model external context from your internal documents. And in this video, I want to cover this third option, which is RAG. I will tell you when to use it, what is general, and how to start using it. So let's start. What is RAG? Retrieval-Augmented Generation. This is a technique that improves a model's response by injecting external context into its prompt at runtime. Instead of relying on pre-trained data, RAG allowed the model to retrieve relevant information from connected data sources, like your uploaded documents, and use that as additional context when generating a response. This is exactly how it works when you use custom GPTs and when you upload your documents into custom GPTs, and next time when you are writing the prompt to your custom GPT, first it would take the data from your documents and use this as a context to generate the answer for your prompt. RAG offers several advantages when compared to traditional text generation methods. And now I want to tell you the reasons why you might want to start using RAG. First one, RAG has access to fresh information. LLMs are limited by their training cutoff dates. RAG overcomes this by injecting up-to-date knowledge from your data source into the model's prompt at runtime. Factual grounding. LLMs can hallucinate or confidently produce incorrect answers. RAG mitigates this by grounding answers in retrieved facts, ensuring that the generated output stays anchored to the actual content from your documents. This reduces hallucinations and increases trustworthiness, especially when the response must adhere to system instructions and safety rules. Token efficiency. Using retrieval can also help fit more relevant context into the model without exceeding token limits. Instead of sending everything, RAG helps pick only the most relevant snippets, which can save both time and cost. But also you need to remember about the relevance, accuracy, and quality. The quality of RAG output depends heavily on what's retrieved. Poor retrieval leads to poor answers. That's why you need curated knowledge bases, good chunking and parsing strategies, and well-structured questions from users. And now I want to tell you a real-world example of usage of RAG. Let's say you're building the GPT to help your support team. So GPT-4 doesn't know your latest product, your updates, and so on. But with RAG, it can pull info from your internal documentation, like different support tickets, and use that to answer that really efficiently. You don't need to rewrite the prompt manually or retrain the model. It just works. And now I wanna tell you how RAG is really implemented. First, we need to remember that RAG is implemented by two phases. First one, setup phase, and the second one is runtime phase. So in this diagram, I showed each step, and now we will go step by step how they implement it and what they are really about. So first, they need to implement setup phase. Basically, it's when you gather in the documents in one place and you are putting this in a vector database. So here I wrote this step by step what you need you to do. First, you need to collect documents that you want to use as internal knowledge for your AI system. Then you need to chunk these documents and embed them. And you need to send these embeddings to the vector database. So you need to understand what is vector database, but basically you can think of this as special database which can store embeddings, and you can easily query this database by embeddings. Because in AI world, everything is embeddings. And if you want to be an AI system which is working really fast and accurate, you need to use embeddings, of course, for this case. So basically, here is the steps. Take the documents in one place, send them to your embedding model, and you now have the embeddings of your documents. And then you need to sort them in the vector database. Here I provided some providers of the vector databases. Here the most popular. It's Pinecone, Chroma, and VV8. You can use any of them, just consider and see the prices and so on. After this step, we have all the embeddings and all our data in the vector database. Now we can move to our next step. Our next step is already runtime phase, and now we can already use this data from our internal knowledge to send requests to LM. So basically, here I described following. Runtime phase consists of following steps. First one, user query. So the user writes the query to our AI system to get some information. Then we will take this user query and we will convert this to embedding, and we only can query our database with embeddings. That's why we take user's query, we convert it to embedding, and now we can ask our database to take the relevant information from our database from this query of the user. Now we got the relevant document, and we can use this document as context for LLM request. And so basically, now in this case, LLM provider would take the original query plus retrieved context, and it would generate the response. And here I describe this in examples. In a simple example, you can think of this as AI support system. So the user writes request, what's return policy? We take this query and we embed them using embedding model. Then we query our vector database with this embedding model. After we got the information from our database as context, most relevant document, we send the LM request with this context and original query, what's return policy. And after LM got us the response, we send it back to the user. And here I describe this also the examples, how it can be implemented in code for those who better understand like in code, how this is implemented. So basically, as I talked before, there are two phases, setup phase and runtime phase. On the setup phase, we set up OpenAI embedding client, and we set up Chroma client. And also you can see that when we set up in Chroma client, we provide the embedding function. So this would be the function would be handling all the embeddings. It would convert the queries to embedding, and yeah. And after this, we send our document that we provided before to our database. As you can see, we don't explicitly embed these documents, but the Chroma client already doing this, but it's like encapsulated. So basically, when we add in these documents, first they are going through our embedding function, and only after they are uploaded to the Chroma. And the next phase is runtime phase. So basically, this is the query of the user, where is the Eiffel Tower? And now we query our vector database with this query. Once again, it's encapsulated, but under the hood, this query first is embedded, and then it queries to our Chroma. And once we got the most relevant information from our database, we use this as a context for our LLM request, as you can see here. And now our AI system has the most relevant information from our internal documents, doesn't matter. And now AI better understand what we need and how to help us. So I guess this is pretty simple, but I want to assure you that this is really cool way of making your AI system smarter, and it sometimes can really solve a lot of your challenges. So let's recap. RAG helps you when your model needs relevant information which updates quickly. Using RAG, you don't need to retrain your AI model every time something new is added to your internal knowledge or something is changed. It works by searching your documents at runtime and adding them to the prompt. It avoids the cost and complexity of fine-tuning because you don't need to retrain it, you just need to add some external sources, use it as a context. And it gives really accurate and context-aware response. But of course you need to remember that RAG doesn't replace fine-tuning or prompt engineering. You also need to consider different options when you're facing with some AI challenge. That's a quick overview of RAG. How does it work and when to use it? If this video helped you, please don't forget to like, subscribe, and see you in the next videos about AI. See ya!